All right, so I need to give you guys trig things.
I like that one.
So the law of sines, which is, okay, let's start with our standing assumptions for the day. So the standing assumption for the day is going to be that I have a triangle, which is not necessarily a right triangle, and it has sides A, B, and C. Yes? And angles A, B, and C. Where do the angles A, B, and C go relative?
Opposite
Opposite of the sides. Cool. So angle A is across from side A. Angle B is across from side B. And up here is angle C. Okay. So law of sines is what? Anybody remember?
Sine of A over A equals sine B.
Okay, it's like sine of A over A is
Sine B over B equals sine C over C.
sine B over B is sine C over C.
Yay! You're done. That's what we need to know.
Yeah, and you can hold your hand over whichever part of this you don't know at the moment. You guys see that? So like, if you don't happen to know anything about the B's, you can cover that part up. If you just don't want to use the part about the B's, you can cover that up. You guys see what I mean by this? So you don't need to write down, what I mean by this is, you do not need to write down all three parts of this at the same time.
Every time.
Because solving that way will be a giant frickin' mess. Pick a pair and use the pair you're on. You guys see that?
Maybe write it like a little triangle, like one equals that one and that one.
Sure, it's trig class today, at least. So let's write the thing in a triangle. You guys see this? And you can use any pair you want. You guys got this? So any side of the triangle you want is okay. You have to remember to be careful with this thing. Why? No. Okay, you have to remember to be careful because there can be issues, especially if angles are close to 90. No.
If you have one at 90, the other two have to fit into 10 somehow. 10? Oh, no, 90.
Yeah, so the issue is when your angles are close to 90, it's not going to be totally obvious what's happening in terms of your triangle. Meaning, here's some side line. Let me just call this 7 units for kicks, right? Here's some angle. Let's say I knew this is 30 degrees. You guys see this? Does that look about right for 30 degrees? Yeah, give or take. I don't know how long this side is, so it goes out there somewhere, right? This would be a 90-degree angle right here, right? But if it's just a little bit off, you guys see if I have a side that's just a little bit longer, that could go to either here or to there.
Oh.
You guys with me on that? Oops, that one's clearly longer. Really needed a compass for this. You guys see that? So let's work together and make a good example. If it was exactly 90, right, we'd have a 30, 90, and the other would be 60. And so then the sides would be let's see, let me put the 7 here.
Then that'd be 3.5 on the right. And then
Okay.
that would be freaking 3.5 root 3.
You guys all see this? So what if it was just a little longer than 3.5? So if I had a triangle where I knew that it had a 30-degree angle, a side of 7, and an opposite side of 4, right? You guys see this? I should be able to solve this using the law of sines. So let me try it. And it's not totally obvious because this is going to be set up this way, right? Initially here, you're going to get some triangle that says there's a 30-degree angle, a side of length 7, and a side of length 4 on the other side there. So then I'm going to apply the law of sines. So what's the law of sines tell me?
It says sine of 30 over 4.
Sine of 30 degrees over 4
Okay.
equals
sine of something over 7.
sine of question mark over 7. You guys all with me on this? So I'm calling that angle there a question mark. That's cool?
Yep.
Okay, so why don't I have the third part of the law of sines here?
You don't need it.
Yeah, because I don't know anything about it, and I don't need it right now. You guys see that? I'm going to need to find that angle, and then I can use the fact that the angles sum to 180 to get this other one. You guys see that? Okay, so let's find that angle. So how am I going to do that?
Multiply by 7.
I'm going to multiply by 7, so I'm going to get 7 sine of 30 degrees over 4 equals sine of question mark. You guys cool with this? Yeah, so we have to inverse sine this, right?
Oh,
You can do sine of 30 degrees turns it to a number. Right?
Okay, cool. Sine of 30 degrees is a number I should be able to get.
it's a nice number too. It says 7 over 8.
So sine of, let's see, 30 is this one, right? 2 and 1. So the sine is 1/2. So I can put that in here. So this is 7 over 8 is sine of question mark.
No, because it's a different triangle than your standard right triangle.
I still know how to get sine of 30. See that?
Sine of 30 is
I don't know that this triangle is similar to that one. In fact, I know it's not.
Sine of 30 always.
But sine of 30 always comes out of the right triangle with 30 in it. You guys see that? So, yeah, I'm literally just evaluating the trig function sine on 30. That's going to tell me about this kind of dotted thing that I put in there originally. It's not going to tell me about this guy because this isn't a right triangle. You guys all good with that? Okay. Can somebody tell me what sine inverse, right? So I'm going to hit both sides with sine inverse, yeah? So I'm going to get question mark, should be sine inverse of 7 over 8. What do you get?
61.04.
No? Yeah. Are you in degrees?
Yeah.
What's that just a little bit longer than?
Okay, so I went a little overboard when I went from 3.5 to 4. But you guys all see this? So what's the issue? Well,
something that doesn't go into sine.
yeah, let me try another thing. So, sine inverse works on which side of the unit circle? You guys remember?
On the first and fourth.
Yeah, sine inverse gives you answers in the right-hand side.
Yeah.
Okay, so here's that angle, 61.04 there. You guys with me on that? Okay. If that's 61.04, sine's the height, right? That means that on the other side here, there's another angle. What's the angle for that? What's the angle in the second quadrant that has the same sign as 61.04 degrees?
151.0.
Good. 180 minus that.
It's 150 something, whatever you said.
You guys see that? Right, I go 180 over, and then I back up that 61.04.
138.96.
Is that right?
Why are you putting the 138 then?
No.
No, I know how you get it, but why are you putting the two angles on it?
So why am I putting both angles in here? Because I'm thinking, hey, quick, punch into your calculator sine of 118.96.
You get 87.5. I'm sorry, 0.87.
Yeah, is that 7/8? What's 7/8?
7 minus divided by 8.
0.875.
Oh shit. You guys see that? I got two answers, right? Because there's two triangles that work here. There's this one, where this angle is 61.04 degrees, and then there's this other one, where that angle is 118.96 degrees.
Oh, okay, I see.
You guys see that?
Two different possible answers.
Yeah. And on these, I can pretty well tell if I have a picture of the triangle which one it is, right? Those look pretty different. But what if that was way closer to 90? Then in my picture, I might not be able to tell, especially if it's the kind of crummy picture that you guys usually get out of me. You guys see that? So you got to be a little careful, especially if they're near 90.
So you say whenever you see a clean angle like 30 degrees or 60 degrees or 45, you should be a little concerned, maybe?
No, I think you should always be a little concerned using the law of sines.
Oh, okay.
It's sometimes able to give you two answers.
When
You
is
guys
it
see
not
that?
able?
When there's only one intersection. So, let me see. If I knew something else about this triangle, maybe, like if I knew how long the other side was,
Okay.
then maybe I wouldn't be able to get two answers.
Go solve for that.
Or if it only hit once, right, if it was a right triangle,
Mm-hmm.
then I would know. You guys all see that?
Alright, how do you choose with the crappy picture between these two?
Sometimes you can't. Sometimes you have
so
to
you
say
just
it's
get both
possible
answers?
that both things are answers.
Oh, okay.
You guys see this? This is a little bit like the quadratic formula, right? In the end you get, oops, there might be two answers. And that's okay. You guys cool with that? Once you get to here, like once you've split it out, if you want to solve the entire triangle, you're going to have to do two different solvings. You guys see that? Because this other angle will be different, obviously. And then when you run law of sines on the other side, there should only be one answer.
Would you even have to go use law of sine?
Ah, good question. What else could you get away with?
Or
But if you have two sides.
You want to think about the Pythagorean theorem, right?
Yeah.
Why is Lauren shaking her head?
Because you're trying to find the side lengths.
That's good. Say that.
It's only for right angles.
Yeah, the Pythagorean theorem only works in right triangles. So what's the Pythagorean theorem for not right triangles? Do you guys remember?
Oh, cosine, that's right.
Yeah, the law of cosines, which will give you only one answer. You guys see that? Cool. Question, Steele? Why does the law of cosines only give you one answer and the law of sines can sometimes screw up and give you two?
It's better.
It's better. Good. Sine inverse does the right-hand side, right?
Yeah.
Cosine does.
And triangle angles live in the top half. You guys see that? Right? Triangle angles live between 0 and 180. So they live in the top half of the unit circle. So this sine inverse crap isn't doing all of that. But the cosine inverse lives up there. And so the only answers it can give you are the triangle angle answers, which is great. You guys see that? Okay, so I'll kill this and we can learn the law of cosine.